drainage. Here we go. First and foremost, you have the definition of acid mine drainage. In the content, you have acid mine drainage, which is the outflow of acidic water from metal mines or coal mines. It also forms when sulfide minerals in rock are exposed to air and water, producing sulfuric acid. Next, we have the formation process. The acid mine drainage forms when sulfide minerals, example pyrite, react with oxygen and water. The role of microorganisms in AMD, we have the microorganisms like Acidobacillus ferroxidans accelerate the AMD formation. These microbes oxidize ferrous ions and sulfur compounds, enhancing acid generation. Here is a picture of the microorganisms. This one is actually Acidobacillus ferroxidans. As we are talking about, we definitely have a source of acid mine drainage. Then we have the sources listed. One, we have mining activities. This is the surface and underground exposed sulfide minerals. We have abandoned mines, legacy site where AMD continues to discharge. We have the tailings and waste rock contains reactive sulfide minerals. We have the open pit mining, large volumes of rock exposed to air and water, which will cause AMD to happen. Next, we have underground mining, mine workings and waste rock contribute to acid mine drainage. Mining activities. These are all sources of AMD. This is a picture to demonstrate our illustrations. We have abandoned mines. This is the legacy issues with abandoned mines that contribute to AMD. The AMD means acid mine drainage. The example is the Berkeley pit. This is the picture. Then we have Montana. This is the picture of the Montana. We have tailings and waste rocks. Tailings are often stored in large impoundments which can generate AMD. Waste rock exposed to air and water can leach acids. We have water pollution. AMD introduces high levels of sulfuric acid and heavy metals into water bodies. The effects are low pH, toxic metal concentrations. Example, we have Fe, which is iron, Al, which is aluminum, C, which is copper. Then we all know soil degradation from junior high school to senior high school. We all know it affects soil pH and contaminates soil with heavy metals. pH is also known as the power of hydrogen. It also results in reduced soil fertility and plant growth. We have impact on aquatic life if there is an experience of AMD. The low pH and metal toxicity affect fish and invertebrate species. In the long run, it makes them die. So we have no fisheries in our water bodies. The example is impact on trout populations in AMD affected regions. As I said, there will be no fisheries in the water for fishing, which will distract or disrupt the ecosystem. You have terrestrial ecosystems. The AMD contamination impacts vegetation and wildlife. Acidified soil affects plant species and reduces habitat quality. The soil is acidic. If you plant, you not get the right vegetation, then the concentration in it can lead to diseases, which is very harmful to the terrestrial ecosystem. This is a picture of how it is. When the soil is acidic, plants are unable to grow. In the long run, there will be drought, then hunger will come to the ecosystem. This is also another clear picture of it. We have the historical context. Copper mining since the 1950s leads to AMD, so it started not now, but earlier on. We have the current issues with large acidic pit lake with elevated metal concentrations. We have the Tasmania, it's an island state of Australia. Historical context, copper mining since the 1890s, which means this started very early, which must be abolished. We have the current issues, long-term MD discharge impacting local rivers and ecosystems. In the long run, when you have acidic soil, it will flow. Or when it's raining, we have particles of the soil entering the water body, which in the long run will contribute to the fisheries and aquatic species dying, which is also a way of disrupting the ecosystem. There's a picture of it. Now, the Iron Mountain Mine, California, a major source of AMD with severe environmental impact. We also have sulfide mines in Sweden, examples of modern mine operation with AMD management. We have the pictures beside it. So a better vision than a clear understanding of what you are talking about. We have other notable examples, as I mentioned. So thank you for the class. I hope what we've done will let you understand every detailed concept, every concept of AMD. This is the end of the slides. Thank you once again. This is group 21.